An exciting day because we are jumping into the stuff we're here for. Um, we're skipping 1-1 because 1-1 is just like a chart that says, this is what you learned in pre-calculus. This is what you're going to learn in calculus. We don't need that chart. So we're jumping into 1-2 and we're going to be talking about limits. So we just got a little preview yesterday on limits, but now we're figuring out what they really are. In this section, in 1-2, we're gonna find out how to find them numerically. And then tomorrow we're gonna figure out how to find them graphically. And so in layman's terms, numerically means we're gonna use our table like we were in our calculator yesterday. And graphically means we're gonna see a picture of them. We're gonna visually see what a limit is. So that's what we'll spend this section on. It'll take us, I'm planning on 3 days for this section. And then we're going to go into 1-3 and we're going to figure out the algebra way to find limits. And then we'll have a quiz on 1-2 and 1-3. So you kind of see how this, you'll learn the pattern, but that's where we're going to do 2 sections and have a quiz. I put homework for 1-2 on Classroom. So that's just so you can kind of work on that, be comfortable with those, and kind of see how that works. Okay, so we're starting today, and what's kind of strange about this is we're starting to figure out what limits are, but I'm going to start with telling you when limits don't work. So there are 3 times you won't have a limit. I don't think this came up in our class. I think it came up in calculus. Did we talk about the Mean Girls quote? Okay, we did. Okay, so it was the Mean Girls quote is the limit does not exist. Well, that's what we're starting with. There are 3 times we won't have a limit. And so we'll get those 3 times kind of written down and talk about those, and then we'll go on to the other things. So 3 reasons why limits will fail to exist is our list we're going to make. And the first reason is this. The behavior differs from the right and the left. And of course, I'm going to explain this. Behavior differs from the right, and the left. I'm going to draw a picture to kind of encapsulate this. Okay, so do you remember yesterday we talked about a limit is all about the y value you're approaching, and it's not what actually happens at the number I'm asking you about. So it's the y value you're approaching. So if I am approaching this value, let's see, so right here, this is the value I'm going to be looking at. When I look from the left, and I want to know what y value that's approaching, wouldn't it be like this number on the y-axis, whatever that is? When I look from the right, isn't it approaching this y value? Are those the same? No. And so another way to think about this, a lot of times it's going to look like a jump. So if the 2 sides are approaching different y values, there's no limit there. Another time that we're going to see this in terms of functions, we're going to, a lot of times piecewise functions have this jump. So when the pieces don't approach the same y value, then they wouldn't have a limit right there. So we have different behavior from the left and the right. And then yesterday, do you remember in our calculators, when we were kind of looking at x values as they approached a certain number, I also had you look on the other side of it because we were actually looking from the left and the right of that value. So when they're different, it won't have a limit right here. And this will click more and more. That's why we take time on this. Okay, so then the second reason is going to be something we are going to say is unbounded behavior. And for this, we also talked about it yesterday. If we have a graph that goes forever and forever up, is that having a y value that it's limited by? No. And I know somebody said it yesterday. What is occurring right here at that value? Yeah. So another way to think about this would be when we have asymptotes. So that's unbounded behavior. And we would say that there's no limit because what y value is stopping that graph? Nothing. It's going to go up towards infinity. There's no limit to that graph. Okay, now the third one is more fun to explain with a calculator. So I'm going to have you get your graphing calculator out for the third reason. And I'm not going to give you the word yet, but I'm going to have you graph in your calculator sine of 1 over x. And remember, we need to be in radian mode. So we'll go to our y1, put sine of 1 over x. Okay, then I'm going to have us do something, but I'm going to also show you some notation up here. It may look familiar, may not. We're going to find the limit of this graph, and then underneath of this, we say what x value we're approaching. So we're going to be approaching the x value of 0. Okay, when you look, isn't it just like a little tiny graph? Just kind of a little heartbeat in the middle. Let me see. Let's plug in. Okay, let's check mode. Yeah, that's good. It should be radian, but it would probably affect with the stat plot. Let's turn it off. Let's turn that. Yeah, let's see if that works. Yeah. That's good. That's good. Yep. Okay, now, just like a little line, little kind of heartbeat. Our calculators have this cool zoom in feature, right? So let's go zoom in, zoom to, hit enter. You can see a little bit more of the heartbeat. Okay, so now, thinking limit-wise, we're approaching the x value of 0 from the left and the right, and we want to see what y value it's approaching. So let's zoom in a little bit more. In fact, you can keep hitting enter over and over again, and it'll keep zooming in. And as we're getting closer to the x value of 0, our goal is we're trying to find the y value that it's limited by. I mean, if you can't see it, try enter again, I guess. Yeah, sure. Let me see yours, Jada. I love it. I love it. Sure. Let me see, Becca. Ooh, let me see your y equals. I like that. Do you mind if I look real quick? We do zoom. Okay, so this is our standard window. I'm gonna do zoom to enter. It somehow just got like off kilter, I think. So now just keep hitting enter. Okay, this has affectionately been called not real mathematical circles, made up circles. The barcode graph, can you see it? Okay, so what y value do you think it's stopping at? It's not really. Okay, so here's what's technically going on. As we get closer and closer to 0, the y values are popping back and forth between 1 and -1. They're going boom, 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 infinitely as you get closer and closer. Your calculators are dumb. You're going to see that a lot this year. Your calculators see these 2 points and they connect the dots, but there's really nothing there. Have you ever had your calculator accidentally draw a vertical asymptote in? Some of the older versions do that. The newer ones are getting better at that. But the calculator sees these 2 points and connects them, and that's why we have all those barcodes. But technically, it's just a bunch of dots going boom, 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 boom. And a limit is all about what y value it's going to stop at. Well, it's not. It's just going back and forth. Hence, why this is going to be on our list of not having a limit. But now we've got to have a name for this. So I'm going to see if you can think of this vocabulary word. Do you know a vocabulary word of something that rotates back and forth, back and forth? There you go. Like an oscillating fan goes like this. So these are called oscillating functions. So this is an oscillating behavior. When they go back and forth like that. And honestly, very rare occurrence. It's probably gonna, I don't know if I know of one that's not trig, and it's just rare, but we have to be all inclusive in our list of things that don't have limits. So we're gonna have, if they have different behaviors, if they're unbounded, or if they have this rare occurrence of oscillation, then they wouldn't have a limit. And these will be rare, but they do happen sometimes. If we created a chart, a little table, we would see y values go 1, -1, 1, -1, 1, -1, and there's no pattern of what they're stopping on. And so that's why we don't have a limit. All right, so those are the 3 times, the only 3 times our answer is going to be they don't exist. Has to fit in those categories. Do you have any questions on any of the 3 that don't exist? Make okay sense? All right, then let's get into ones that work. And so this, like I said earlier, we're going to find them numerically. So we're going to create charts. So we dabbled in this yesterday a little bit when we had our charts on our calculator, but now we're going to be making our own, and that's going to be finding them numerically. Okay, so the one we're going to start off with is, I'm going to write it in the notation we're going to get used to. The limit as x approaches -1, and the function is going to be x plus 4 over 2x plus 1. So I'll let you copy that down. And then I'm going to have you copy this chart, this little table. It's going to be 2 rows. It'll always be 2 rows, and we're going to make this one 8 columns. And then for our columns, the first column, these are going to be our x and our y values. Now, as we look at the other spots to fill in, there are 7 columns. In that middle of the 7 is the x value that we actually are approaching. So I'm going to put -1 there. That's the one we're going to look at, coming at it from the left and from the right. And then, so we can kind of see a pattern, what we're going to do is kind of like gradually get closer and closer to -1. So like I'm going to start off a 1/10 away. So I'm a 1/10 away from 1. We'll see what's happening. Then I'm going to get closer and I'm going to go 100th away. So -1.01. And then I'm going to go 1,000th away. And so I'm like creeping up on it. And as I creep up on it, hopefully I'm going to see some kind of pattern. Well, I got to creep up on it on the other side. So like out here, I'm going to start a 1/10 away. And then 100th away. And then 1,000th away. Okay, now we're going to use our calculator capabilities to help us out with this. Some of you may know this trick. I don't know if you use this in pre-calc or not, but we're going to go to our y1 and we're going to type in our function. So remember, put parentheses around your numerator and your denominator. And then we're going to go to table set again. So that was second window. Your table start doesn't really matter at this point in your delta table. What matters is we're going to change our independent to ask. So independent to ask, and then go to your table, so second graph. And now we can type in all 7 of those x values, and it's going to give us our y value. So we'll know right now if we have everything typed in right. So if we do -1.1, we should get -2.417. Okay, so let's go ahead and get the rest of those numbers. We'll type those in, get that chart started to be filled out. Okay, there's a way to fix that. Yeah, no, yeah, but it'll be nice to get the decimal too. I forget where that's at. Oh, go to second window, and in your table set, make your independent ask. Let's see, it's somewhere here, Grace, but I can't remember where. Oh, that's not what I want. I might have to Google that. Yeah, for now we'll get the fractions, but I'll Google that just because that'll be nice to have your decimals. Okay, let me Google that now then. Limit. Oh, equals -3. Yeah, we don't have to put the y part. Yep, good question. Anything else right now we can think of? Okay, let's try another one. Okay, next one we'll try the limit as x approaches 5 of x plus 2 over x minus 4. We're going to try a chart out for this, a little table. So we'll have our 8 columns, our 2 rows. Five is going to be between all the numbers. We're going to approach 5 from the left and the right. So like I start a 10th away, get a little bit closer, 100th away, 1,000th away. And then I'm going to let you go on your calculators and try this out. See if you remember where to go from here. And these, you're going to get several that have your 4 numbers out. So we'll definitely put all 4 of those when they give those to us. Feeling okay? Okay, now what would be our actual answer to this limit question? 7. It's like too easy right now. You're like, am I in calculus? Let's go for an anomaly next. Let's try one out that's not as clear cut. Are we okay right now before we move to the next one? Okay, next one is we're going to have the limit as x is 2. And we're going to have x squared minus 4 over x minus 2. I'll let you go for the chart setup and everything, and then we'll check our answers. What y value are both sides approaching? 4. So what's our answer to this limit? 4. Again, it's not about what happens at the number. It's about what the sides are going towards. Let me draw you a picture of what this graph looks like. I drew it wrong. That's the graph. So as we look from the left, what y values are those getting closer to? 4. As we look from the right, what y values are those getting closer to? 4. It doesn't matter that there's actually a hole right there. It's just about what they're approaching. And so that's what it will look like in our chart when something like that is going on. That's what happens. Okay, I'm going to show you another anomaly. Charts are tedious, aren't they? You'll be glad to get past the charts part because they just are some writing. Okay, the next one we're going to try is this one. The limit as x approaches 3 of x plus 5 over x minus 3. Let's try this one. Is it okay that there's an error at 3? Yeah, that part's not concerning. It's okay. It's all about the approach. From the left, as you get closer to 3, what y value is it like sneaking up on? A very high number. So like it's like, isn't it like getting higher and higher and higher the more you get towards that 3? Is it like the other ones, you see how they like just gradually were getting close to a number? Are these moving gradually to one number? No, they're getting higher and higher. They're like shooting up. What's that that's going on there? Yeah. On the other side, oh, sorry, I did that wrong. They're shooting down. These are getting lower. The other side, those are getting higher, right? So what's going on, you don't have to follow my hand motions. I'll actually draw it for you. What's actually going on is this. Is there a limit to the y values there? No. Which of the three reasons would this be? The asymptote, the unbounded behavior. And so this might be what the chart looks like when we don't have a limit. They aren't like sneaking up and just gradually getting closer to a y value. They're exponentially getting bigger or exponentially getting smaller. And that's what it will look like when we have an asymptote. All right, how are we feeling so far? Yeah. Okay, great. So our answer would be DNE, does not exist. Okay, we're going to stop there for notes today. Tomorrow we're going to pick up the next thing. But I'm going to give us some time now to look at those chapter P tests. So you can kind of see how you did. You saw your grade yesterday. Maya, I'm going to try to grade yours real quick. But I'm going to show you guys.